Hello again. We're going to be dividing radical expressions and at the same time be rationalizing the denominator, or that will be a sub-concept of dividing radical expressions. So I wrote out 4 different fractions. I wrote out 2 over 8, square root of 2 over 8, square root of 2 divided by 8, and 2 over square root of 8. Actually, the quantity of 2 over 8 under the square root is probably how I should have said that one. So I'm going to go ahead and I'm going to simplify these. 2 over 8 reduces to 1/4. Finito. You're done. Nothing more you can do. Square root of 2 over 8 works a little bit differently. There are a couple ways to go ahead and do it. I wouldn't advise you to always do it one way or the other. It just depends on what's easier. But I'll show you both ways anyways. What you do is you reduce what's in the fraction before you go ahead and take the square root. All of it's under the square root, so you're fine. 2 over 8 reduces to 1/4. But it's all under the square root. All I did was reduce the fraction before I took the square root. So what you then do is you split it into the square root of 1 over the square root of 4 equals, square root of 1 is 1, square root of 4 is 2. Now you're done. And some students say, well, that seems like it takes too many steps, and I think I could do it easier. Well, I don't disagree that you can't. The problem with that is that some students don't recognize it when they learn it. And sometimes reducing the fraction actually makes it better, even though it seems like it takes an extra step. I'll show you the other way that you could do this problem. Instead of reducing the fraction under the square root, the whole fraction is under the square root, you can go ahead and you can split it into square root 2 over square root 8. And it works the same way. Square root 2 over square root 8. 2 over 8 is 1/4. Square root 2 over square root 8 is square root 1 over square root 4. And then square root of 1 is 1. Square root of 4 is 2. And it's the same exact answer that we did, except it was a different way. I like to tell my students this, and I'm very honest, that if you have a fraction and it's all under the square root, see if you can reduce the fraction first. It just makes it a little bit more approachable. That's my opinion, mind you. You might disagree, but everybody thinks differently. Next one, square root 2 over 8. If one number is a square root and the other isn't, you can't divide it. And it's not going to come out to square root 1 over 4. It's not going to come out to 1/4. It's not going to come out to square root 1 over 4. There's nothing you can do here. The denominator is rationalized, which means it's a a natural number. It's not negative, it's not a fraction, it's not a decimal in the denominator. It's fine. You can't do anything with the square root of 2. If you could split it, then you would have to do this. If this was a square root of 20, you'd have to make it 2 radical 5. And you'd have to split it and simplify that. Nothing too big. So there's nothing you can really do. Actually, you know what? While we're at it, let's do the square root of 20 over 8, because I think that would be a very good example. Square root 20 over 8. I said you can't do anything with that denominator for right now. But you can split the square root of 20 into 5 and 4 and 2 and 2. Circle your primes. So the square root of 20 is actually 2 square root 5 over 8. You can divide the natural numbers together. You can't divide square root 5 by a natural number, but you can divide these two. And that turns out to be 1 radical 5 over 4. Pretty fascinating in my opinion. And that's it. Now the last problem is rationalizing the denominator. You can't leave it as the square root of 8. And very simply speaking, you can't leave it as the square root of 8 because it's a decimal. Or it's a it's a decimal actually. And it's illegal to put a decimal in a denominator. And the reason why, very simply speaking, is because when you're dividing, the original concept of division was how much you have divided by people. And you can't have a decimal of people. It's either 1 person, 2 person, 3 person, 4 person, etc. So what you have to do is something called rationalizing the denominator. And we'll talk about its, I guess, more difficult step, conjugates, when we end up rationalizing expressions, which isn't for right now. But we'll go ahead and do this. So 2 square root 8, you can't divide it because one's a whole number, one's a square root. What you can do is rationalize it, and you could actually simplify the square root of 8 before you do this, but that's a mess too. So if you want to rationalize a square root, if you want to get rid of a square root, what you do is you multiply it by itself. If you multiply it by itself, watch what happens. What you do on the bottom, you do on the top. And you're left with 2 root 8, because you can't do anything there yet, over square root 8 times square root 8 is square root 64, but it's also 8. You got rid of the square root. See how that works? You make it a natural number. We're not done. You can't divide square root 8 by 8. You could divide 2 by 8, but hold on for a second. Don't be too ambitious. I want to figure out what the square root of 8 is. So if I didn't know what a square root was off the top of my head, I would just go somewhere else on my paper, and I'd split it, 4 and 2, 2 and 2, circle the primes. So the square root of 8 is actually 2 root 2, but there was another 2 in front, over 8, so 2 times 2 is 4, root 2 over 8, 4 over 8 is 1/2, and students always think, oh, isn't it 2? No. 8 divided by 4 is 2. What I show my students is a trick here. It's not really a trick, it's just, they don't know what 4 over 8 is. Not good with fractions. So I ask them, what's 8 divided by 4? And they're like, it's 2. Okay, yeah, it's 2 over 1. So instead of 2 over 1, just go 1 over 2, you know. I don't know if that makes sense, but it does usually for them when I explain it. 8 divided by 4 is 2, 2 over 1, but now it's just like flipped. So it's 1 over 2, root 2. Maybe somebody will think that makes sense. Tell me if it makes sense, actually. I'd appreciate that. That's 1 square root 2 over 2. Yeah. Not a bad problem. I'm going to go ahead and erase this because I want free range to do what I want on this particular problem right here. Free root. Okay. That's enough room. I'm looking at this problem, square root of 3 over 2, well, square root of the quantity 3 over 2b. I can't reduce the fraction 3 over 2b, so what I'm going to do is I'm going to split them. Square root of 3 over square root of 2b, and I say it's illegal to have a root in the denominator, and then once in a while you'll have a student who says, are they going to call the police? And I'm like, okay. Although I do actually appreciate the joke because it's so bad, it's something that I would say. And I do appreciate bad math jokes. So I've got the square root of 3 over the square root of 2b. I want to rationalize the denominator. Basically what that means is I want to get rid of the square root. In order to get rid of the square root, you just multiply it by itself. Well, what is itself is the square root of 2b. 2b or not 2b. What you do in the... I thought that was funny. What you do in the denominator, you do in the numerator. And here's what you get. Square root of 2b times square root of 2b is just 2b. And square root 3 times square root 2b is square root. Now since they're both under the same kind of a root, it's just 6. You can't divide the b's out because this one's under a root and this one's not. This 6 is under a root and the 2's not. Done. So we're going to do a quick reminder on adding and subtracting radicals, although we kind of already did that when we were foiling, but it never hurts to do it again anyways. But with that said, I hope that wasn't terrible. I hope it was actually pretty useful. Have a good day for now. Goodbye.